pick up here in the middle of this section, we talked about precipitation reactions. These are the steps to follow when writing an equation for a precipitation reaction. So you need the formulas for the two reactants, and then you need to write the formulas of the products. I'm going to show you in a little more detail through the examples. I like to write below the equation the formulas for the ions in the reactants, and then we're going to swap partners and predict the products that way. Looking at the formulas for the products, then you need to decide, is either of them insoluble? If both of your products are soluble in water, then there is no reaction. And so you don't actually have to balance it or anything. So if all your all your products are soluble, just write no reaction. If there are any that are insoluble, you need to write the formulas out and indicate which one's the solid and which one's aqueous, and then balance the equation. So those are the steps. Let's do a couple examples. Write an equation for the precipitation reaction that occurs, if any, when ammonium chloride and iron 3 nitrate are mixed. So this is how I recommend doing this problem. Here we're given names, not formulas. So we need to figure out the formulas for these. These are both ionic compounds. Writing the formula for an ionic compound, you need the formulas for the ions with their charges so you can figure out how to put them together. So I like to just say, well, I'm going to write my equation up here. I'm going to make some notes to myself down a little further. So ammonium chloride, 2 ions. I need the formula for the ammonium ion, NH4 plus. And I need the formula for chloride, Cl minus. And then I figure out how to put those together by looking at the charges. +1, -1. I just need one of each. NH4Cl. In equations like this, it's more important to write the state symbols. Is that soluble or insoluble? Soluble. The first line of the solubility rules table says that ammonium compounds are soluble, no exceptions. So I'm going to put AQ for its state. Iron 3 nitrate. Iron 3 is Fe3+. The Roman numeral tells me the charge. Nitrate is NO3- because I memorized it. Then we look at the charges. +3, -1. I need 3 nitrates to make up for the charge on 1 iron. So I'm going to have Fe, NO3, 3. I put parentheses around the nitrate because it's a polyatomic ion, and I'm going to have more than one. I've got 3 of them, so I need parentheses. If you have a monatomic ion and you have more than one, you do not use parentheses. Is this soluble or insoluble? Soluble. All nitrate compounds are soluble, no exceptions. There are my reactants. Now I need to predict the products. Remember the analogy of people going to a party and mingling?
Was it a good analogy?
It was good, thank you. I'm actually, it's one of my favorites.
Just copyright that one.
So here we have ammonium and chloride going to the party and iron 3 and nitrate going to the party. What we're going to do is we're going to see when these guys mingle and mix together, is there going to be any chemistry? So opposite charges, you have to have opposite charges. So we've got +3 with the -1 chloride, positive and negative, and here we're going to try out ammonium and nitrate and see how they get along. So I'm going to identify what the partners are, and then over here I'm going to write those ions again. So I'm going to try out Fe3+ with Cl-, and I'm going to try out ammonium ion with nitrate ion. See what happens. It doesn't matter whether you write the iron and the chloride first or put them in the second. That doesn't matter. What does matter is that the positive ion always goes first, the negative ion is always second in that pair. It's like formal wedding invitation is always Mr. and Mrs. It's never Mrs. and Mr. so-and-so. Why? It's not a conspiracy. It's not a dig against women or anything like that. It's just tradition. Everybody, it's just we all do it the same way because it makes it easier. okay, when things are consistent. So it's always the positive and then the negative. Well, we could just go ahead and write these formulas, but maybe let's look and see, is either of these insoluble? So FeCl3,
No. I mean,
is it soluble?
yeah.
It is soluble. So the chart on the third row, the halides, chloride is one of them. Chlorides are generally soluble except for silver, mercury 2, that's actually mercury 1. Anyway, it doesn't matter, it's not mercury, or lead 2. This is not an exception. This one's soluble. How about this one, ammonium nitrate? Very soluble. There's no precipitate that forms. There's no reaction. So we write no reaction, or, often even lazier than that, capital N, capital R. Which, you've seen those little traffic speed things, they're solar powered. You drive past and it tells you what your speed is. There's one by my house, and a lot of times there's a tree, and so it doesn't always get enough power, and so it'll say NR. And I know it stands for no reading, but as I'm driving along, I think no reaction, because I'm a chemist. NR means no reaction. So nothing happened? Well, there was a physical change. The things got mixed together, but there was no chemical reaction. Any questions? Let's do another one. Write an equation for the precipitation reaction that occurs, if any, when sodium hydroxide and copper 2 bromide are mixed. You're going to follow the same process. I'm given names of ionic compounds. I need to write their formulas first. So sodium ion, Na+, because sodium is in group 1. Hydroxide is OH- because we memorize it. So sodium hydroxide would be NaOH. I don't need any parentheses because I only have one polyatomic ion. Is this compound soluble? Yes. Sodium compounds are soluble, no exceptions. AQ. Plus copper 2 bromide. And copper 2 is Cu 2+. Bromide is Br minus. Is that a train or an idiot in the car? Yeah, I thought so.
Maybe it's an idiot in a car getting hit by a train.
Or maybe it's an idiot in a car imitating a train.
Could be your husband saying Happy Valentine's Day from the train.
Maybe it's an idiot riding in their car on one of those train cars that carries cars, and he's honking while the train's going by. Copper 2 bromide, plus 2 minus 1. Oops, I almost did it. I almost put parentheses around the bromine. I don't need parentheses around bromine. It's a monatomic ion. So CuBr2, is that soluble? So bromides are generally soluble except for silver, mercury, and lead. So this is soluble. If you practice, eventually you'll be able to picture that chart in your head. You really will. Okay, so now what we need to do is predict the products. So we're going to swap partners again. I'm going to try copper with hydroxide and sodium with bromide. So sodium with the bromide and copper 2 with hydroxide. Is sodium bromide soluble or insoluble? Soluble. Sodium compounds are soluble, no exceptions. How about copper 2 hydroxide? Insoluble. If you go to the bottom of the chart, hydroxide compounds are generally insoluble, except the exceptions are barium, strontium, and calcium. So that's not an exception. So we do need to finish this. We can't just write NR. Plus 1, minus 1. I put those two together. NaBr, we already determined that this is soluble. So AQ. Copper 2 hydroxide, I need 2 hydroxides to even out the charge on the copper ion. Because there's 2 of those, I put a subscript 2 on the outside of the parentheses. And we've determined that that's our precipitate. So now we have reactants and products, and we can balance the equation. So we have 1 sodium and 1 sodium. We have 1 hydroxide and 2 hydroxides. So I need to go back over here and put a 2 in front of sodium hydroxide. And now my hydroxides are fine, but I changed the sodium. So 2 sodiums, I need to put a 2 over here in front of the sodium bromide. So I've got 2 sodiums. And I'm over here, let's check bromine. 2 bromines, 2 bromines, 1 copper, 1 copper. Any questions?